Right, let's try that again. Let's try that again in a different application. Well, it's the same application. It's Mozilla Firefox again. Only this time I'm doing it via Discord. Posted all of these to Discord. Right. I tried doing this with just have each one in its own tab so you could see them full width of the screen. Didn't work. The whole video was just a single still from another video. And now they're not dynamic tabs or something like that. So it doesn't... The software I'm using to record this doesn't update what images, what video it's recording. It records the audio, but it just stays stuck on a still of the video that isn't on the screen anymore. Yeah. Last night, during an atrocious dumpster fire, Craig was, that's FTFE, talking to Humbert or Herbert or, I don't know, Hogswatch? Nah, he's not cool enough to be called Hogswatch. Some jackass. It was basically like listening to a 14-year-old and a 12-year-old arguing in the playground. One of the things that came up was a Miles Davis observation from Traprain Law of some, open quote, mountains, close quote, the far side of the Queensferry crossing. Traprain Law is at 210 metres. For some reason, when preparing this, I got 221 metres from somewhere, but never mind, it being only 210 metres makes this worse. And you got the Queensferry crossing. This bridge, shown here, end on. At the same elevation, which above a flat plane would give you eye level. There was this big mumbled thing, and after the start of this recording, I have no place to complain about anybody mumbling. Why am I on 0 frames per second, for God's sake? About whether or not this is eye level or the same elevation or both. But if it was flat, this would be eye level as well as the same elevation. And so would a point somewhere in the mountain over here. You just do that, and then scroll down here, and good grief, what on earth is she doing in my video? Well, that's what I say. Better scroll back up just a little. I was looking at her thinking, it's kind of hot, it's improving things. Anyway, yeah, with a bit of luck, this will actually be on the screen now that I've done that. I would say that actually, where Craig said the angular size of an object is twice the arctan of g over 2r. Why g? Why r? I don't know. That's accurate if you're looking square on at the midpoint. If you're looking square down the wall in the middle of a multi-storey car park, exactly halfway along it, halfway across it, whatever, then the angular size of one half of it is half of its width. Sorry, has a tangent that is half of its width divided by your distance to the near face. So the angular size of the whole thing is twice the arctan of half the width over distance, which is the same as twice the arctan of full width over twice the distance, because fractions work like that. For a mountain, the angular height above eye level is this difference in heights. Sorry, has a tangent which is this difference in heights divided by your distance. I'm used to working in radians, and with tiny angles, the tangent is so close to being the same thing as the angle, I keep forgetting to mention it. And the part below eye level has an angular height of your elevation above sea level divided by the distance. Has an angular height whose tangent is your elevation above sea level divided by the distance. I just said I keep forgetting it, and I forgot it again. If we're looking at an island across open water here, the lower part would have an angular size whose tangent is your elevation, again, but divided by the distance from you to the near shore, not to the highest point, which would give you a slightly wider angle and a slightly greater total angular size. This is the BBC. Yes. In this case, we're not interested in the part below eye level. The bits below eye level, below the red line in the Miles Davis image, aren't of interest. What's of interest is what is, or in many cases isn't, shown above that red line. Need more beer so I can speak properly. Over this flat plane, this level, deep blue sea level, would be the upper part of the mountain. And indeed one of the highest, I think it's at 570 metres, is shown above that red line, just the very top part of it, which is angle A. So I can close that now, and with a bit of luck, Fraps will actually notice that I have closed it. I'm just going to scroll down here and scroll back up again, just to annoy everybody watching this, and then open the next one, which I think is the next image that I was planning to use in a video that would have been presented far better than this, because it wouldn't have looked like this. Right. From that formula for A, whose tangent is elevation of mountaintop minus your elevation, divided by the distance to the mountaintop, we can rearrange things. We can take arctan from the right to the left and turn it into tangent, say tan A equals difference in elevations divided by distance. Multiply both sides by the distance. Tan A times the distance is the difference in elevations. Divide both sides by tan A. The distance to the mountaintop is the difference in elevations divided by the tangent of the angle between eye level and mountaintop. Upwards. Upwards is important there. Excuse me. This is where I got 220, this is where I put 221 metres in. Where I got it from, I don't know. 511 minus 221 metres. It would actually be slightly bigger angles than this, because it's only 210, not 221, whatever. If it's actually at eye level, the angle between it and eye level is 0, and we have this big problem, highlighted here in red text. Error, division by 0. Yeah. It's gone horribly wrong. You tried to divide by 0, your calculator is now just putting up an E, or error, on the screen, because you done fucked up, boy. So if we go with this arbitrary small angle of 0.05 degrees, tiny, right? Human eye can resolve smaller angles than that, never mind a camera. And we put in these actual figures and get 290 metres of elevation distance. 290 metres divided by the tangent of this small angle, which is itself a tiny angle, that being about that many radians, we get that the mountain is 332 kilometres away, out here in the North Sea, according to Google Maps. On the screen, that line is slightly curved. You're not imagining it, there is curvature. Hey, we're not imagining it, there is curvature. Anyway, yeah, that's because this is Google Maps giving one projection, which rather than a globe looking straight down on the middle of it, or an alternative that would work. Right, I think it didn't upload these to the channel in quite the right order, but that's the same with a little bit of extra on the right, because of course I don't have to take this arbitrary small angle. I can take a very precise small angle, ridiculously precise small angle, 8 significant figures, there was no need. 120 degrees is an arbitrary generic field of view horizontally. I don't agree with. You can see more than that. Camera might take that as a standard, no zoom field of view. My camera has a 40 times zoom, which would mean it zooms into 4 degrees horizontal, and it has a 4:3 aspect ratio. That will give you 3 degrees vertical. It has a 4288 by 3216 pixel sensor, so at full zoom, each pixel should be just slightly less than 1 millidegree. The tangent of which is 0.00001628. If you divide 290 metres, that difference in elevation, by that tiny, tiny number, you get 178 million metres. No, you don't. Decimal point is there. You get 17.8 million metres. Or, 18,000 kilometres. Just more familiar unit for such a big distance. Which for flurfs in the Great Plains of the USA is 11,068 miles, which is a little bit more than this 206 miles. So, I made another image, and yes, it is not the next one in line because uploading things correctly, why would I want to upload things correctly? There we go. That is 17,800 and some kilometres. Across here, across the edge of Newfoundland, across southeast Florida, western Cuba, northeast Honduras, northern edge of El Salvador, way out across the Pacific, most of the way to New Zealand. In particular, the Continental Divide runs down here. You can actually see it on the Google Maps image because they've nicely included shadows on the east slopes of the mountains as if it's coming up to sunset. And you'll be looking across this part of the Continental Divide, which may or may not be above. Hey, let's check. Highest point, Honduras. Never mind that image. Somebody said love was in the air, and that's my response. Highest point in Honduras is population 9,265 million. That's not the highest point. That's an advert for a hotel. Geography of Honduras. There we go. The highest peaks at an elevation of 2,500, an elevation of 2,850. Highest point El Salvador, 2,700 meters. Right, you would see them. You'd be able to see, 1 pixel high, anything at 511 meters, all the way out to there. This much closer at 2,700, was that, meters? You'd see that. That'd be above eye level by several pixels. Like, that's only a 290 difference, and now we're looking at, 8 pixels above eye level? They're not there in the screenshot. Okay. Scroll up for goodness sake. There. This was not part of the video I planned, but whatever. Somewhere, oh yeah, that one came up last and it shouldn't have. This one was next. This is the same map with a different projection, azimuthal equidistant, centered on Traprain Law. Skimming Newfoundland, southeast Florida, western Cuba, northeast corner of Honduras, across El Salvador, out into the Pacific, most of the way to New Zealand. Same thing. And someone may say, hey, what? In fact, yes, someone may do that. Oi, pay attention to me. Oi, I'm here. Look at me. I want to say something. And point at this and say that actually the North Pole is up here. That should be the centre of the map, not Traprain Law. Thinking they're being clever. Oh, that makes it worse, because this is what you get if you centre it at the North Pole. From Traprain Law across the same to the Scottish coast, you don't get Newfoundland, Florida, Cuba, Honduras, El Salvador, and out this way across the Pacific. You get very close to Ecuador, and then across Peru. And Ecuador is quite famous for its volcanoes, including, somewhere on this line here, Volcan Cayambe, whose southern slopes are the highest elevation on the equator, and which has the distinction of being the point with the highest linear velocity due to Earth's rotation. It's not Aconcagua, which is the furthest from Earth's centre, but further from the equator, and it's not Everest over here, there-ish I think, which is the highest elevation above sea level, but it is the furthest out from the Earth's axis, and therefore going fastest. But anyway, there's your line of sight if it was a straight line on this flat plane centred on the North Pole. And you would be looking across some really tall mountains. Cayambe is in my video of the question of scale. Yeah, there you go. Chimborazo at 6,263 meters above sea level. You notice that. And that's Volcan Cayambe, elevation 5790. More than 10 times as high as one of the hills that's lined up with the summits of the tops of the towers in the bridge in the Miles Davis picture. So I have those formulae for how far away it would have to be to get down to 1 pixel, even if it was only 511 meters, only 290 meters above you, and it's way too far. And to get down to actually at eye level, division by 0, it would be infinitely far away. In other words, this so-called flat Earth theory is bollocks.